Hi everyone. So I'm going to talk about cost optimization in Kubernetes clusters. So I've not discussed it till now, but this has become very important, and especially with growth in the nodes and growth in the containers and pods, it's very important to control the costs, whether your cluster is on the cloud or if it's on the prem. So there are multiple tools that are available for cost optimization. But what is cost optimization, and where do we see the resources being overutilized or underutilized, and then how do we make sure that the resources that are underutilized, they are freed up so that we get the costs back. So if you see in a Kubernetes cluster, there is a control plane and then there are worker nodes. So control plane is mostly, if you're having a managed cluster, then it will be controlled by the provider. For example, in AWS EKS, yeah, you don't have to worry about the control plane because that is controlled by Amazon Web Services. But still, in your cluster, you own the worker nodes. So worker nodes is one piece where we want to make sure that the nodes are as per the resource requirement. And where does the resource requirement come from? That comes from the container. That comes from each container, each pod that is deployed in the node. So in a pod, there is something on a deployment, right? So the deployment has the deployment spec. There is something which is known as called a resources. So that resources controls the limit and request. So it is very important to have resources mentioned, in every deployment. In fact, many companies force it as part of the like linting or checking before the deployment is done, that this section, this spec is not empty, because otherwise this is the way to control your resources. So what does resources does? It has limits and requests. So when the orchestrator, the Kubernetes, is trying to deploy the pod and a node, how does it know that I want to deploy, should I deploy on worker node 1 or 2 or 3 or 4? So it's going to check on the this resources section. So it has limits and requests. So requests, the field, if you see there is CPU and memory, that will always be less than the limits. So when the orchestra is looking for a node to deploy the pod, it checks for the request. That means the container requires 250M, which is virtual CPU, and like that is like 1/4 of a CPU, and it requires 1 GB memory. And then it looks at the limit. So limit is always greater than request, which means that max resource it will use is like half CPU and 1.5 GB. So when it looks for a node, it checks for the limit. It will check, okay, if there is enough capacity on the node, like if it with memory and CPU, then it will deploy the pod to that node. So this piece is very important. That's why every container when it's deployed should have resources set, which are limits and requests. Now this is all. It's also possible that now in a worker, when you have multiple worker nodes, and what if there is what if there is no like if you are deploying not one, right? You mostly are deploying multiple pods, and so if multiple pods are getting deployed and the capacity is not available, that's the time when the techniques such as autoscaler they kick in, and then if there is not enough capacity, it will automatically create a new node, and then it will deploy the pod over there. So that's also part of the whole optimization. But then what is important is also like the other way, right? Now for example, when I have, how do I know that I have the right numbers over here? Because most of the times people we don't look at exactly what the requirement is. Not normally in the non-prod environment we should do this tuning. So when we deploy a pod, we should test how many requests were coming in and what's the capacity. So there are multiple tools like Dynatrace and all, they're available, so you can check what is your consumption versus what is your like what the container or the how much is it using versus how much it is allocated. So that metrics is very important over here. That's the first thing. So that should be definitely deployed on your cluster. That will give you the visibility, the usage visibility. And now, so for example, if you're not using enough, but you've given that, oh, I want like 2 CPUs, but my application is only using half a CPU, that means you're wasting that 1.5. So that is where cost optimization comes in. So there are multiple tools available these days which help to convert that number into dollars. So for example, if I'm deploying and I am wasting memory and CPU, so then it calculates approximately how much cost you can save if you optimize it. So I need something called as an optimization tool that also optimizes and tells me, okay, reduce this and do this, and then yeah, this is how can save. And then definitely I want some alerts, like if my usage is going higher, then I want to be alerted. So one of the tools, there are many tools available. One is called kubecost, and another one is called cloudability, and there are many are available out there. But if let's look at kubecost, because kubecost, it's based on open source tool. And then kubecost is a tool, right? It's a cost monitoring and optimization tool, and this is for cost allocation. It will tell you the cost optimization insights, and same thing with cloudability. So it tells, so for example, if you see over here, this is I picked from their website. So it says that in a cluster and in particular namespace, how much is the CPU and RAM and storage network that's being used, and how much is the efficiency. And also if you go to, it has a screen for optimization insights. So it tells, okay, how much you can, even cloudability has it. It is called aptio cloudability. So it will show you, okay, this is the consumption versus this is this resources that are being, that are sitting idle. And then you can increase the efficiency by, so this number shouldn't be low, because your efficiency should be good. So in that case, that your cost versus, your usage versus your allocation is at par. So if you see, so if you look at this website, right, so this is website for kubecost. So kubecost is on open source. So, and it comes for Amazon EKS. It can be deployed and everywhere it can be deployed separately. So this is the website, and if you look at the installation docs, there are different ways to install it, but simple is it's a Helm install. So if you just use GitHub, and then you can simply create a namespace and install kubecost on it. And once the kubecost is installed, now there are two options in it, which are either it's self-hosted and or cloud. So most of the people go for, right, because that means you can directly see all your data on the cloud. Like similarly, this is called cloudability. This is if you see the products, cloudability is a product for Kubernetes, and it suggests the optimization also. So if you see, go back to here. So there are two ways to do it. So if you're hosting in the cloud, then what you runs in your cluster is basically an agent. So every cluster will have agent running, and that agent will be able to get the data, get the metrics. It sends the data to cloud, and then that's where you can use it to analyze, and you can see various metrics, and then it's based on the recommendation. You can tweak your resources, and then you can save the cost. So the cost optimization has become very popular in the recent, especially like with FinOps and everything. Operational costs should be less, and as much as we can save, it reduces the waste.